All right, we've got 3 done. Let's look at this one. So here we go. All right, so horizontal rifle. I guess they have this rifle hammered down. In other words, because let's say the end of my pen is the rifle. When you fire a rifle, it has a tendency to go up like this. I mean, in the real world, you shoot a gun, the recoil, or a rifle, guns are on naval ships. But anyway, boom, goes like this. So this is not right unless they have it secured so that it's going to go perfectly straight, which they would do in a Forstnick's lab. All right, in the Forstnick Science Lab, it would be absolutely straight, so you could get the muzzle velocity, and they'll get the muzzle velocity by how far it dropped. They know how far the target is that they have away from it, and they know they can measure the distance that it dropped, so therefore they can get the time of it traveled this distance, this wide distance, so therefore they know the muzzle velocity, okay, of the gun. And so at um, Smith and Wesson manufacturing and Colt manufacturing. I mean, that's what they do. All right. So anyway, let's take a look at this rifle. All right. Problem 3. Got a rifle. I'm just going to draw the end of it. Shoots a bullet. 670 meters per second. And it's going to drop just a little bit and hit the target here. And so Y initial is at 0.025. Y final is at 0. So once again, and they want us to calculate the range. What do we need? We need the time. All right? And for this problem, we just go, okay, so what's the time? Time is the square root of 2 times that 0.025 divided by 9.8. Because we're good at that by now. Now that is going to be a really, really small time. Really small. So we've got 2 times 0.025 divided by 9.8. Take square root. Don't forget to do that. 0.0, so the time is equal to 0.0714 seconds. Okay? Yeah. Okay. So there's the time. So now I know the range. The range is going to equal V naught x times t, which equals 670 meters per second times 0.0714 seconds. Seconds are going to cancel. 47.8 meters. So about 150 yards away. It's pretty quick. Blink of an eye, people. Blink of an eye is 0.2 seconds. That's really fast. All right. Okay. Now, we could also use this to calculate V final again. So V final in the y direction would be V naught in the y direction is equal to 0 minus G times G times 0.0714 seconds. So you take 9.8 times 0.0714 seconds, and you wind up with about 0.7 seconds, 0.699 meters per second. Now, that's a negative. Do we need to worry about that? Because when I square this and compare it to the square of this, it's 0. I mean, when we're looking at this 0.025 error compared to the 670 meters, it pretty much went straight. All right, but it did have a little bit of a drop. All right, so we're done here. Out here. Good. How do I turn this